In nuclear physics, for course in 5th semester, we will today discuss about the unit 2nd, nuclear radiation decay process. Here alpha disintegration and its theory. So alpha disintegration means we are disintegrating alpha particle from the nucleus. As we know, nucleons is a word which is used for the proton and neutron collectively in nucleus. If number of proton, if we want to know, that is we can show with the atomic number, and if A is a mass number, then we can find out the value of neutron, that is A minus B. It means atomic number, and it will be atomic number will be deducted from the mass number. Proton carry positive charges, and there is an electrostatic force of repulsive force between them. These forces of repulsion between protons are unlimited range. The repulsive disruptive force of nucleus is approximately Z square, where Z is a atomic number. Now if we are discussing this is in the sense of gravitational force, then we can say gravitational force of attraction between nucleons is very weak. Similarly, nuclear attractive force between the nucleons is very short, of very short range. Total binding energy in the nucleus is approximately proportional to the mass number A. If we are discussing this with in sense of high energy of alpha particle, this alpha particle is a favor of high energy emission, and alpha particle has 2 proton and 2 neutrons. It has high binding energy, that is more than 28 MeV, because alpha particle mass sufficiently smaller than that of its constituent nucleons. So the formation of alpha particle with within nucleons make available the kinetic energy of particle must have escaped from the nucleons. If we want to compute the known masses of each particle, that is there we will have to arrange the parent and daughter nuclei. Energy Q, that energy Q is here, that is indicated for disintegration energy. This is released when various particles are emitted by heavy nucleons. Q can be written as mp minus md plus mx, and it will be multiplied with c square, where mp is the mass number of parent or initial nucleus, md is a mass of daughter or final nucleus, mx is the mass of particle that is emitted. Similarly here we will discuss the nuclei, that nuclei which contains more than 210 or more nucleons are of so large, so short range nucleus force that hold them together, hardly able to counterbalance mutual repulsive force between the protons. Or you can say these are those nucleus which maybe comes under the category of unstable nucleons. Other decay needed energy supplied from outside of the nucleus, while in alpha decay, increasing nucleus stability by reducing their size and is energetically possible. In this we can discuss that alpha decay from that uranium-92 238 nucleons is accompanied by release of 5.4 MeV. This integration of energy of alpha decay agree with predicted value based upon nuclear masses involved in process. Radioactive nuclei which atomic number Z is greater than 82 or mass that is greater than 208 spontaneously disintegrate with the parent nucleus decay, decaying with the daughter nucleus and an alpha particle, that is helium nucleus. Here we can also discuss this in this sense that alpha particle and daughter nucleus, those will both will have kinetic energy if parent nucleus at rest. Similarly, the necessary condition for the emission of alpha particle that may be discussed as sum of the masses of daughter nucleus alpha particle must be less than the mass of parent nucleus. If here we are considering T alpha, that is kinetic energy of alpha particle, and T alpha that can be said never quite equal to the disintegration energy of Q, because since momentum is conserved, here we are saying that 10 MeV, that is 9.83, nearly equal to 98 98.10. That is a small amount of kinetic energy. Here T alpha is related to Q and mass number, that is A. Alpha particle that can be energy for alpha particle that can be written T alpha is equal to A minus 4 divided by A into Q. Momentum, this is momentum is conservation for or law of conservation of energy. Emission of proton requires 6.4 MeV, where we can say the helium nucleons that requires 9.6 MeV to be supplied from outside. So the emission of individual proton or two helium, as we are helium 2 3 nucleus is not energetically possible.